See, Chuck, I could be funny too, Chuck.
Yeah, no, not with that.
Damn, Chuck is cold. Chuck don't play. Chuck
Ice
don't play.
cold.
Blooded brother. Yeah. So golf has continually just innovated. I mean, even if you look at the clubs, used to be called woods because they're made out of wood, irons because it used to be made out of iron, but they're not made out of wood anymore. They're made out of titanium or composite of carbon fiber. The irons aren't iron, they're steel, and just golf.
So they're still calling them woods and iron. Wait, they should call them, pass me the titanium, right? Why don't they do that?
Right.
Because they're just stuck in their ways, I guess. I don't know.
Okay.
Yeah.
This was another one of your students, wasn't it, Judd?
So what happened here? What happened with your student?
Yeah.
What happened with your student?
All right, so we were doing golf. One of my students, Caroline, we approached Bobby Jones Golf Course, which is a course named after a famous Georgia Tech grad, just up the road a little bit, and said, there's a lot of innovation in golf. I'm a material scientist. What's some unique research out there? And so we began to talk to them about additive manufacturing, ways to make putters instead of just being cast, where you take a shape and you pour molten metal into it, or forged, which is where you take a solid piece of metal and smash it and shape it into whatever it needs to be, like a putter head.
And your student is a biomedical engineer, if I my
Caroline's
notes are correct on her.
Caroline's graduating this semester. In fact, got a good job. That's the problem with my workforce, is that they have this nasty habit of graduating all the time. So
Damn,
I know. So I'm
you
always
just flunk them,
replacing.
and they have to repeat the class.
Oh,
These are your options available to you.
That's amazing.
Those are available for graduate students. We don't flunk them. We just hold on to them for 5, 6, 7 years.
For more years, yeah.
Well, my advisor told me getting a PhD was all about knowing more and more about less and less. And once I know everything about nothing, that's when she'd give me the degree. So here I am.
There you go.
Okay.
So I don't understand.
Anyway,
I don't understand what the purpose. Because I don't know enough about golf. What could you do to a putter? Because that seems to be the exact same motion for every single golfer I've ever seen, and the ball is already on the flattest surface that there is on the course, which is the green. So what do you do to a putter to change that process?
It seems like that would be the least susceptible thing in golf to technological innovation.
Right. Yeah.
And in a way, you're right. That's why there hasn't been too much technological innovation. But we partnered with Stuart Sink, who's a famous Tech alum as well.
That's the best name for a golfer ever.
It is. Sink that putt. And he's the best putter.
Stuart Sink?
Yeah.
He's widely recognized as the best putter out there for But we talked to him, and there's a variety of different things. Well, so we did additive manufacturing, so we're able to make putters with distributed metal throughout, and you can see this is hollow. The other aspect is
But just to be clear, it means the density is not constant across the putter or the width or through its depth?
Correct. We can change the center of gravity and the moment of inertia. And this is just 3D printed with steel. We did this as practice because really we want to use two different materials. One that's very dense, like tungsten, and one that's much, much lighter, not as dense, like aluminum. And then you can really move the weight around to because you want to influence the ball to roll. You don't want to hit the ball.
So is that the only
and make it
process, Judd,
skid.
that will allow that? 3D printing is the only process that we have right now that allows this variation of density?
It would allow a gradient. Right now, what they do is they'll take a piece of these two different materials and put them together and weld them. And so it's a very
so there'll be an abrupt
function.
change. I get it.
Yeah.
Right.
You need a billow and an anvil and a really hot fire.
Yeah, exactly. So we looked at we looked at the face inserts. This is really primitive. This was version 1.0. So we looked at changing the polymeric face inserts. They have different angles. So depending on the length of the grass, you can have 0.5 degree versus 1 degree, and you can put a couple together and make 2.5 or whatever degrees to allow that ball to not get ground into the surface when you putt. The other aspect you mentioned earlier, Chuck, that you see everybody with the same swing, and that has to do with what's known as toe hang. So I'm going to see if this works. So this is version 2. We added some weight tracks in here on the bottom.
So you're holding right now your 3D printed putter.
Yep. Right. This was also 3D printed. We did a little differently. One of the main reasons that all these holes are here is that it was too heavy. And so we did a second design that takes out just hundreds of grams of weight to get it more comfortable. And one of the things that you see if I hold it like this, the face is basically flat. That's called toe hang. And so depending on where this part of the putter attaches, that's called the hosel. We have the first adjustable hosel out here. So if I move
Is that allowed, judges?
Yeah, well,
Gary,
that's-
Chuck?
Now, see, the thing is, golf
For the
is
time being.
mired in 1,000,000,008 rules for everything. And so, have they come back and give you the okay on this, Judd?
Yeah. So I just moved that hosel, and now see how it is slanted? See how it's a different.
yes.
So the connecting point here, we can move it around, and based on my swing versus Chuck's swings, Gary's swing, you
can
want that in a different
compensate.
place.
Right.
And as your swing gets better, Chuck, with practice, you can move it to a different spot. Otherwise, you have to, with all current technology, you have to just go buy another putter, or you can sometimes bend this, like heat it up and bend it a little bit. So that's a key innovation.
So it's an all-in-one. It's an all-in-one putter in a sense.
You've basically made a modular putter that can
Putter, yeah,
that changes with your game and changes with your skill level. That's ingenious.
We also Britt and now since Caroline's graduating, I told you I got to keep the workforce going. So Britt is the next student that's working on here. Instead of the face inserts, we had a little challenge with the face inserts, kind of making an unpleasant clacking sound when you putted, which messes with putters' heads.
Oh God.
I know, right.
They're divas. They're
Jesus.
divas.
How much more fragile can these frickin' golfers be?
Just stop.
Everybody's got-
you can't even crunch a potato chip while they're
Exactly.
swinging.
Everybody's already super silent. Okay, the people who are commenting are just like, okay, and he's approaching.
They're whispering, and they're in a sound booth someplace else.
They're right. They're 4 blocks away, and they're just like, well, he's about to make it now, baby. Look at what he's doing right now. Okay, so, well, I mean,
The trouble is, if you were going to do something, Chuck.
Wait a minute. Now you're telling me that the sound of the ball hitting the putter may disturb these
It
guys.
didn't sound good. Yeah.
That is. I hate golf so much right now.
I know, but you'd think the first thing they do is just turn the volume down on the clothes. They all have the loudest clothes, and they'd be worried about that first. So the thing is, how do you alter the polymer in the face? Because you're kind of thinking you need a more rubberized contact surface to lessen the noise. But if you're putting more rubberized content in there, then you've got deformation when you connect with the ball. So how did you overcome that, Judd? Because everybody hates clacking.
Wait a minute, Judd. Let me ask it a different way.
All right.
So how exactly did you change the face of the putter? Because, of course, the deformation may...
Exactly.
Yeah, Chuck's got that golf speak really good there. Okay.
It is great. I'm gonna have to practice that when we go to a break. The polymer itself, there's a variety of different polymeric compounds that can be explored. We did this with a company called Carbon 3D that's located up the street here in Atlanta. They printed this. We also can do metal ones as well, and it varies between putter to putter. The whole game of golf is what they call a game of feel. So the way I feel putting is different than any of y'all feel. And so the clacking occurred when we is really due to the way we attach it to this face. So we're going to get back to having these face inserts because they've got them currently in putters, but we wanted to explore some other things. And so Britt moved to this with a standard face. But because of putting, you want to promote the ball rolling immediately off the putter as opposed to sliding a little bit and then starting rolling. You can see the grooves, perhaps.
Yes, there are horizontal grooves going across the face of the putter.
But they are not periodic. They are at different spacing between each other. So if you're slightly above or slightly below the center of gravity of the ball, you'll have a different amount of these grooves grabbing it to promote rolling.
You can control it. Now, isn't there a regulation at the length of the grass on the green? So what are you saying for tall, high grass and slow grass? If you're putting, you're on the green. And so isn't that all very stubby grass?
It is stubby grass, but it can be differences of millimeters, and that can make a difference. The grass itself is not regulated. All sorts of stuff with this putter are regulated, from the width and the depth of those grooves to the length and all sorts of other different things.
Wow. That is amazing. So now I need